In this video, we're going to learn how to do long division with decimals. This is going to be the first of 2 videos. So for our vocabulary, we're going to remind ourselves that a remainder is what's left when a number doesn't divide evenly. And in this video, you're going to learn how to represent remainders with decimals rather than just writing them as a fraction. And second, we're going to remind ourselves what the long division steps are. So we use the acronym of DMSB, which stands for division, multiplication, subtraction, and bring down. So that's the order of the steps that we use when we do long division. All right, so we're going to be focusing on figuring out how do we use decimals to show remainders. So we're just going to do some examples. So first, we are going to write our acronym up at the top: divide, multiply, subtract, bring down, so that we don't forget what to do next. Help us track what we're doing. And then for our first example, we are going to do 851 divided by 2. And you'll notice that I'm using grid this time, and that I want you to do the same. I've done this so that I can really clearly show that one digit goes in each box. So we're going to do 851 divided by 2. I'm hoping that a lot of us actually already feel pretty confident in this. And if that's you, then go ahead and just solve it with me as we go. So first, we're going to see how many times 2 goes into 8. Goes in 4 times. That was the divide step. Then we multiply. 4 times 2, we subtract and get 0, we bring down the 5, and now we're back at the start at the divide step. And this is one spot where people sometimes make mistakes. Important to note that we're now dividing into the new number we've created down here. So we do 2 goes into 5 how many times? It goes in twice, because it goes in exactly twice without running over, right? So it goes in 2 times. Now we're back at multiply. That gives us 4. We subtract and get 1. We bring down and get 11. Back at the start again. How many times does 2 go into 11? Goes in 5. Multiply, subtract. And now we have a problem, because now we have nothing to bring down, but we've used up all our numbers and we don't have a 0. So in order to do this, we're going to use the fact that 851 is equivalent to 851.0. We are going to add a 0.0 in our original problem. And that'll allow us to bring down a 0. And then we can just pick up right where we left off. 2 goes into now 10 5 times. And then 5 times 2 is 10. We subtract, we get 0. And that's what we want. We want to end with a 0 like that once we've run out of digits to pull down. But if we look at our answer, 4,255, that looks way too big. We've got to put in our decimal. So our decimal should go always in the exact same spot that it was in the problem. That's why it's so important to keep things lined up. So our answer was 425.5. Let's go ahead and try a few more examples. All right, for our next example, we're going to do 9,571 divided by 4. Go ahead and pause. See how far you can get. Once you think you have it, go ahead and press play to see how I solved. If you get stuck, don't worry about it. Just give it your best shot and then press play and fix it. Four goes into 15 3 times, and the quotient goes on top. And 4 goes into 37 9 times, and so the 9 goes up top. 4 goes into 11 twice, so the 2 goes up top, and 2 times 4 is 8. So now we're at that spot where we need to add a decimal and a 0 because we haven't ended yet. We still have this leftover 3, this remainder 3. So we're going to make it into a 30 so that we can see how many times our 4 goes in, which is 7 times. And we're not going to forget that decimal up top, matching the spot that it is down below. And that gives us 28. We subtract. Look, we have to bring down another 0. We don't need to put in another decimal because obviously we only have 1 decimal per number. And this time it finally goes in the way we want. 4 goes into 25 times exactly. So we know we're done. So you should have had that 9,571 divided by 4 gives you 2,392 and 75 hundredths. All right, this time we're going to do another one. We're going to do 500 divided by 6. Go ahead and give it a shot now. Press play when you're ready. This one starts out a little differently because 6 can't go into 5. It's too big, so you have to move over a digit and see how many times 6 goes into 50 rather than just into 5, which is 8 times. And since we were going into the 50 and not into the 5, make sure that you put your 8 lined up with the 0 for 50 rather than above the 5, because 6 doesn't go into 5 8 times, it goes into 50 8 times. All right, so we got pretty quickly to the spot where we need to add a decimal, both in the problem and the answer, an extra 0 to bring down to make another 20. Now at this point, you might say, hey, look, we just did this. We just did 6 goes into 20. Well, let's do it again. We get 3. Once again, that gives us 18. We subtract. We get another 2. We put on a 0. We bring down another 1. We get another 0. 6 goes into 20 3 times again. Multiply, we get 18. And hopefully you're noticing that this is just going to keep going on and on and on. We're going to keep getting 3 after 3 after 3 after 3 after 3 forever, as long as we keep being willing to do this problem, which shouldn't be for very long. So instead, in math, I'm going to put the little dots here showing that this is keeping going. In math, we have a shorthand to show when this happens, when we have an infinitely repeating decimal, a decimal that does not terminate is what it's called. It continues. So what we do is we say that this is 83.3, and then we put a bar above the 3, showing that it continues on forever. So I'm going to say that this equals 83.3 repeating, is how you say that. 83.3 repeating. All right, let's go ahead and do your practice problem now. For your practice problem, you're going to do 97 divided by 8. Make sure to show all your work. Be careful about lining up your digits. Use your graph paper strategically. We will check this in class tomorrow.